Hello again. So in our last video we end up creating our solid simulation based on the solid solver shelf tool. So this guy here, in case you're just joining, and now we will continue on creating the necessary files to generate the sources for the Pyro simulations. So because we had two separate objects, they come in as one cache, but because we have took precautions, so we can separate these caches now. So let's start with that. If we do a middle mouse, we should see point groups name base sim, ship sim, which means then we can use a blast so we can separate these objects, and this should give me just the tower. And if I go another blast and say, actually let me see if this is the, we need to select base sim and ship sim, so not base tower, base sim. Give it a second to update. Okay, base sim and ship sim. Okay, so we have our objects separate. So the way the you can see some stretched faces here. They're not really stretched. It's because Houdini is able to chop and cut, let's say, to the degree that this model already had before going in to simulation. So if we subdivide this a bit more along the height of this, we could have get better cutting instead of these triangular shapes, but that has a little bit of a performance impact. However, this is sufficient for now for the purpose of this tutorial. Okay, so we have our two objects. So in we can excuse me. What I want to do is, now I want to do a little bit of a cleanup, and I want to cache this out for rendering purposes later. So what do we not need? We almost don't need anything, so now that's gonna make a big difference. Group delete, like delete everything, and then attribute delete, like delete everything except we may need I guess we're gonna need velocity, so we can have motion blur, which we can calculate later on, but why? We already have the information. If you want to do some, ideally base position is like kind of like the rest, so you may want to keep that as well. This way we can add for lighting purposes we can add displacement. If we had the inner faces, because our shot is so far, we didn't create inner TEDs, so inner surfaces, but if we had that, we could use base P to stick displacement. It's kind of like a reference position, rest position in Houdini, P-ref in RenderMan or Katana, in case you use either. I think that's all I want to keep. There is nothing here I can use. I'm just checking with my other scene just in case. Now that's good. Okay, and let's get rid of these guys. Also, if we had UVs, you would ideally like to keep them, obviously. Well, we have UVs, but let me see. if they make any sense. Could be from my old models. No, this is not very usable. Okay, so we have now everything except, sorry. Now we have a very let's see what is the difference from 128 to 116. Well, it didn't make much difference, but it did some. And let's apply the same thing to the other guy. Okay, and this is also now clean from this, all the unnecessary stuff. Let's put 2 nulls so we can define what these are. Out. What? Oh, what's going on? What is the shortcut? Oh, there it is. Okay. Okay, let's call this out. Come on. It's because I move as I move the mouse, I'm still clicking, and then my tablet is registering and clicks away from the keyboard. Out, base, render. Okay, these are base render, copy paste, and then this will be our ship render. Out, ship render. So we can cache these guys out at this stage. Let's call it base sim cache, and let's call this ship sim cache, and let's give this a green color. Okay, and I'm going to set this to be cached on the background. I need a faster disk, and we need to only cache from this range. And since file cache does not have, but do we need to see them? No, that's fine. Okay, let's save again. Every time we change something to run a background cache, we need to save. And come on, select both, save to, save disk. I think it should, multiple selections should launch both. Okay, cool. Let this be monitored here. Okay, so now what we're going to do next is we will create some source points that has some attributes so we can use to emit particles that we can use as a source for our volume simulation, so we can make faster iterations. And to do that, we're going to start with the ship. Where is our first frame? So 1141. Wait, this is the ship? Wow, okay. This is the base. This is the ship. Where is it? Here. So let's scatter some points. Well, actually, I don't want the wings, so please get rid of those. No, go away. Okay, the hand selection is fine for now. Okay, and let's scatter some points. Just baking at the back is slowing down my machine. To follow my RAM usage. We're fine. Okay. No, we don't want to relax points. Okay. So let's set the number to 400,000, sorry. 400,000 and let's give these points an identity by calling them f at base equals 0, because these are the points not on the base. And then I have some points on the ground, which was, I think, I was using for. Okay, yeah. So what we want is also I think at this stage we want to find out an intersection point between these points that are traveling on the ship that are intersecting where the base points are, and as soon as we detect some proximity, this is where we're going to start emitting things. And the reason I'm using points is because my geometry may or may not have enough definition. In that case, points scattered along the surface is going to have much more density, and it's going to give us a more accurate intersection point. So let's bring in our. Actually, I'm going to pause one of these and let it finish after the next one. Okay. So I'm going to bring in my ground. Now let's lock this. So let's find the ground. It was here. Mountain collision cache. I think it's this guy. Yes, it is. Well, actually, we don't need the extruded version, do we? No. Let's take this guy, because this one is the extruded. We just need the surface, which means we just need this, which is easier to follow. Okay. But I don't need the whole area, so I guess this is better, because this was the cut version that we did to create a collision object for the other simulation. Okay, so let's get back into base crash. If we open this up, we should get our ground. We should scatter points on top of this object as well. Oh, where is it? Okay, yeah, there. Which way was it? I think this way. This way, yes. So let's scatter some points on this. We could also actually paint some areas, just scatter more points there. But I think, well, we may. Yeah, let's optimize this, because in my pre-made scene I didn't, but let's do it that way, because I think it's better. So let's visualize the ship. And where does it, well, it's a big ship actually. Let's see. So it's mostly, we can probably avoid anything beyond this line. Anyway, let's see. If we need to, we will. Remember, we are preparing a very base scenario, so we can have a first pass, but a pretty cool first pass that covers the whole thing, because it's extremely important in the industry to present something also to present something. A cool looking explosion is or a simulation is not good enough, because it has to work in the shot context, it has to work in the sequence. So in my personal experience, I always prefer to check the shot before, the shot after, the 2 shots after, 3 shots after, 2 shots before, see if it works in the shot context. See, and sometimes you get shots like you're making a smoke, and for some reason maybe you were not available that day or the next day, and this shot is given to somebody else, and then somebody else is doing that next shot that is supposed to be linked to your shot, and then things get tangled up very easily in the production because due dates change all the time, and then you make a smoke, and then the next guy sitting next to you is making a smoke for the next shot, and people don't end up speaking to each other just to see 2 days later, 3 days later, that oh, it's not working because you're 2 frames early, I'm 3 frames late. That's why it's quite important to pay really good attention to these minor details. Okay, let's put 2 million points on this. 2 million points. Well, but the thing is, when you put more than 1 million, there's a max point count here, so let's disable that so we can actually put 2 million points. And okay, cool. I just want to check something. So I always change that to pixels. 1 point per pixel. This is usually much faster to show it on the screen. So if I show my frame rate, so this is 120 now. I think I don't think there's that many points yet now, but I think this should slow it down. And if you have like 100 million points, it makes a huge deal of a difference. So stick to pixels, I would say. Don't struggle while trying to view sprites, 100,000 sprites coming from Flip Shaft tool. It's really not productive. Okay, so let's get 2 million points on our ground plane, on our environment. So let's put another angle. Let's okay, just note something. Actually, this value that I said here was come on, go. Base equals, wait, this is, where is it? This is the ship, right? This is the ship. Yeah, I put a base equals 1. I am not sure why, but I'm gonna stick to that now because I don't want to break the settings. So this guy this guy that is coming from the environment is f at base equals 0, f at sand equals 1. So we gave some random attributes to these guys. Which I'm saying here is that basically all of you are sand, none of you is base. And I have my ship and saying this is all base equals 1. So maybe we should change it to like an emitter or something, but we shall see. So now we need to do a similar thing for the base itself. Let's scatter some points on this guy. Remove relax iterations, put 400,000. These numbers are not really that important. Trial and error. Let's put another wrangle. And we now now set the attributes f at base equals 0, and I have f at spark equals 1. Okay, and now we're gonna merge base to the ground. Where is our base to the ground? So let's bring the ground to the left here. Okay, so what do we have? We have base, we have sand, we have spark. This looks right. Okay. And then we will do an attribute transfer from the ship to the ground. How is our baking going? If it finishes, I'm going to be very happy, so I can speed up. So I assume in scenarios like this, an Intel i7900 will be around 20 to 30% faster, whereas my Threadripper just makes the difference during Mantra renders or Flip simulations or Pyro simulations, basically anything that multi-threads well. So it's always a there's always a catch, basically. Okay, now we have the transfer. So we are basically transferring base. Let me put this on manual so I can fix this part faster. Okay, so we are transferring base, sand, and spark from this guy to this guy, and the values are 0.68. 0.68. So in some of you may have noticed, some of you, if you have been following, in 16.5 there's a really good feature that basically if anything goes bold, it means that something has changed out of default settings here. So pay attention. That's going to help make things basically a lot easier. Okay, now we want to isolate some of these points based on this transfer. Actually, let me visualize that for you. I want to go to a frame where there's an intersection happening, because I don't want to just drop nodes to explain what's happening. So we have ship going through, and then we did some mumbo jumbo, transfer attributes and all that stuff, and on bunch of points. And how are we going to use this? Why are we going to use this? Wait for this to handle that. Okay, oh, okay, we need to go back to a few more frames. I think I have points on this other guy. I'm going to resume this one. So which one is this? Base crash. Which task is this? Let me see if we have points here. This is the ship. This is the base. Oh yeah, that should be fine. Okay. Here is the transfer. So if you drop in a visualize swap, okay. Actually, I'm gonna pause this, but you can have yourself. When you drop this, just bake it. Pause the video and bake it, and then continue. I would say. Okay, so if you put a visualize swap now, we can see what are we doing with all these nodes. There's something is cooking that shouldn't be cooking. Interplate. Why interplate? Okay. Base, ramp, Makes no sense. Okay. Oh, all right. We caught something because something's not working. Let's investigate. Because we should have some varying numbers. It seems like we don't. Okay. So let's check. We have this guy. Okay. And okay, this is the ground. This is our base. These are merged. And okay, let's fix that attribute values regardless. This is base. So what is this? This is not the base. Let's do this properly. This is the base. Okay, and I'm gonna get rid of this. I'm changing what I did before a little bit to probably a better way. And let's bring the ship. This blast is causing problems. And this is the this is, let's call this the ship. Well, don't need to this. Let's call this base equals 0. Come on. Okay. So now what we want is to generate some emission points based on intersections, literally. So this guy is crashing into this, and these two are crashing into this. So let's do that. Okay. So let's get some points on top of the ship. Now let's get some points on top of this. Okay, so let's do an attribute transfer from ship to base. So we have this value called base here and base here, right? Oh, because then I want to set the okay, so let's give this a new name. So this blast 4 is giving me a headache. 1 second. I'm going to, for now, I'm going to put a time shift because that's always clicking there. And we're not calling for a different frame, so I'm not entirely sure why it's doing that. So what I'm going to do is I'm going to, come on, menu, because this is time dependent. So, but why is it calling? Why is it trying to cook it? I'm not sure. Let's go delete. This should now speed things up, I believe. Okay. And this is still posted. Okay, so this was what? Base 1. This was base 0. So okay, let's say crash air changing attributes. Okay, let's go crash equals 1, crash equals 0. Okay, crash equals 0. Wait, 1 0. Okay. So now let's get the attribute right. Crash and probably, I don't know, 1/2 meter, and let's see what that looks like. Well, I need to use to visualize, so I'm trying to get used to it. It should be here. Come on, show me. Why is that showing? Okay. 3 points, an attribute called crash, that I want a ramped attribute that is definitely varying at this level. Oh, there it is. I just have to select it. Okay, so that's where the ship is currently passing very nearby or through or intersecting with this guy, and this is definitely where we should be emitting sparks or whatever. So if we visualize that, you can see that's definitely our source for something. But let's give it a little bit more distance maybe. Yeah, so it's a bit more interesting. Okay, cool. So this is one. So what we want is to get these two guys also and get the same thing from here. Okay, and which means that these two also are going to give us a value that is happening on the ground level. So let's merge these guys now. This guy, I guess we can just do that, skipping that. Let's move this here. Okay, and now let's put an attribute. We can do the same thing here. But then I want to give this a new name because I think I'm going to use the ground for a different source to emit different color or something. Somehow I want to be able to. Hey, what's this? What did I press? SD? Oh, I never played with this. Okay. Node size to show ring, grid spacing. Cool, I'll play with it. So where are we? Okay, let's call this one. Well, let's stick to it now for now. Okay, this guy is here, this guy is here. If we do that as well. But I think we need to go further down in time range. Okay, cool. We have one issue here because that's going to continuously emit. So what we want now is to detect, filter all this out by moving objects. So I want to use you if you're only intersecting and moving somehow. But these points are not moving, so how do we... So we need to do the opposite, like this. These guys. Right, let's go right to it now. I'm not sure. We'll figure out something. Okay, so now what I want is, first of all, I definitely want to isolate these points, this guy, because that's where the intersection is happening. If you go back a little bit, we can check better. And let's put an wrangle, attribute wrangle. And let's say if f at crash is bigger than 0, not really, sorry, is not equal to 0. No, it's less than, let's start with 0.5. Get out of my simulation screen. I do not need you. Let's do the same for here, but we need to, I think we can, this is always 0, but so what happens if we reverse this guy? Let me see. So this is always moving. How come it's always moving? Oh no, it's not. Okay, so let me try something. Should be, so this is always crash. Let's try a smaller number. No, let me check what are the values here. What's the range here? 0.5 to 1, right? Okay, so if it's less than 1, that's okay. If it's less than 0.6, okay. If it's more than 0.6, that's not what we want. That's not the moving part. Okay. So this is the. I'm a little confused. 1 second. It's a bit early here. So we want to keep the white area, but not all of it. Oh, maybe I need to get this in here. Would that be the case? Let's try. Yeah, I should have stuck to my tutorial. Anyway, so I'll figure it out. One thing for sure that we need to use this, and then what happens is that so we need to use the ship. Yeah, that's what we did. We got the ship and the base. Okay, so maybe what we can do is at this level I can say float moving equals length 2 at 3, and if moving is equal to 0, remove point at pt num, so don't even take transfers and everything into consideration. Okay, so move the part that are not moving, so maybe we can also not equal, but if moving is less than, let's give it a value. So less than, if it's 1, let's see how fast it is. Okay, maybe 0.5. What is wrong with the keyboard today? 0.5. Okay, so let's stick to that, which means there won't be anything seen that is not moving, because we only want source from moving objects that are intersecting with each other. Or we could have, I guess, I wonder if we could have just used Boolean to detect intersection. Yeah, that's the new tool, right? Okay, but this is gonna work regardless, except we need to use. Now this guy is okay. 1 second. Let's go a bit forward. Why is not changing? Oh, because it's 50%. Oh, this one. Okay, we need to resume so we can see it better. Oh, because we're time shifting. Time shift is running. Okay. Okay, because deleting every frame. That's why it was slow. Okay, well, we have to check. So I'm gonna undo that. I'm gonna do that for now. Bypass that so it's a bit faster, I guess. Come somewhere here. So now what do we need to get rid of? This is that, because these are all the points. Yeah, I think we need to do all this separately. Yeah, I don't think we can merge this to this. Okay, so let's get the ship. Let's get the ship version. So this is the ground that ship is going through or touching. Right? Come. Yeah. Yeah, that's where we were wrong. Get rid of those. So this is ground intersection. This is ground intersection. This is base intersection. This is ground intersection, and then we need to do the same thing for the base. because base pieces are also flying around. So let's see. Okay, I'm gonna recap this because it got a little confusing. Okay, so we have our base that is flying around. Okay, and we bring in the ground. We do a little attribute transfer of values that, sorry, this is here. It's crash, so this is crash 0, this is crash 1. Just give different values. It's the crash that is being transferred, and here we're gonna now do the opposite. If the crash is bigger than 0.2. Okay. The problem is, there's one problem with this, is that we don't want to continuously emit because this base is always there. So I think what we need to do is to calculate, because we have this attribute speed, right? So we can, where's that speed that we just wrote? We can get this guy in there. So let's copy that float. This part is going to be a little bit hard to follow, I think. Let's export this with add moving, and then let's transfer that as well. Okay. And then also use that to keep points or not to keep points. So we can say if, we can write this in two ways, but let's do it like that. If crash, so okay, so what we're gonna do is if crash is bigger than 0.2 and f moving is not equal to 0, then the condition is right. Is equal to 0, then the condition is right. No? Oh my god, okay. Wait a second. Wait, what? Okay, so this is, how come this should be 0 here? Let's visualize our values to see if we're doing something wrong. I want to see moving. As a ramp. Actually, this should work automatically. Yeah, so that's the part I want only. So I can just use that. Oh, of course, yes. Makes no sense that we need to use crash, because we can just say we're just transferring the velocities, we're just transferring speed from one guy to another, and then saying just keep those guys, and that makes total sense. Okay. Oh wow, was all right. Sometimes the brain goes for a whole day. So so what? Okay, let me recap this because this got just a bit complicated, right? So what I did, I cached out my animations, my simulations. I scattered points on them. Okay, and the first thing I did is, which we're gonna label them now. I got my ship points, ship scatter, base scatter. Okay, I got my ship points and I gave them an attribute called crash equals 1. I get my base attributes and I first measured the speed actually, if we, okay, let's do that. 1 second. Let's do that. And I also measure my speed of my ship points, and this is gonna work now. Okay, finally. Are these all the points? No. Okay. So I got my I measured the speed of my boat points that I scattered on my geo, and I brought in my ground scatter, and I gave it an attribute of base equals 0 sand. I don't need that anymore, and I don't need that anymore also, actually, sorry, because that was the previous plan. I deviated quite a lot from my original scene on the other monitor. So I call this crash equals 1, and this guy, we don't even need the crash anymore, because we're using speed only. So here are my all moving objects. From the simulation that has the speed attribute calculated from here. Okay, and but this is using length 2. This is not actually so meter per second. They're not going 7,570 meters per second. It's just length 2 is so much faster to calculate. It's not really necessary. You can also use length, this guy. And then I'm transferring this speed information to my static points that are resting on the ground, and then I'm saying, show me where there is movement and remove everything else, basically. And this is only going to give me the points where there is a intersection, I think. The other thing we could, well, we can do so many things. We could just possibly create a volume out of these guys and do a sampling. There's just way too many ways to do things in Houdini. So it's really, I think I should probably show that maybe later if the time allows. Okay, so here are points that are, something is not right. Again, I think, 1 second, let's check. This is not very responsive. These are all the points that are, maybe the distance is too small. Let's put a visualize. Let's check this again. Here, this guy. So we're checking speed. Moving. Yes. And I don't see anything here. Excuse me. How are we going to fix this? This should have been a simple step. Okay, this makes no sense. There should be some values here. It's just, I think the visualization is not working fine. Okay, so these are the moving pieces. Anything that is intersecting. Oh, wait, what? I think this is finished, maybe. Yeah. Okay. So anything that is intersecting with this guy should light up. That is also moving. So it should be a bit more than what we are seeing, or our distance is maybe too short. I need to get that right. No, that's correct. Yeah, that is correct. Okay, well, it was correct. I was just wrong. Maybe it was a visualization thing. Maybe it was because baking loading something. Okay, so we have the emission points finally from the ground. Okay, and then we have the emission points from our first crash, and obviously we want to cache this because I don't want to go through these attribute transfers. Hard disk space is cheap. I suggest getting a good SSD and a big spinning drive. Comes handy. Okay, so however, I might want to do something different between these points, because these are only on the ground and these are only on the base. So I think I would like to keep that information in case I want to, because I think these will be like sparky. These will be this part will be sandy. So let's save that as well. The one thing that I think would be cool is that if we get the normals, so we can define. So if a ship comes like this, if a piece comes like this, the particles can go that way. Yeah, I think that would be nice. Okay, for that to work, I am going to transfer the velocities as well, so I know the vectors of crashing objects in case I want to do something else. This one I think already has those coming from up there. Okay, so let's get rid of that speed attribute, which we can calculate from here anyway. Alright, I just need that and that. And this guy is almost correct. So let's do that as well. No, not you. You. Okay. Let me check if that's correct, and now we're going to cache it out, so our pop simulation will be much faster to iterate. Okay, let's put a null. Menu. Actually, what we can do is, since these are just light points, let's cache it out like this. Let's call it, can we use an attribute? I can do that after, doesn't matter. Let's call this ground source. Let's call this spark source. Spark source. Okay, let's put file cache again. Let's call this ground source cached, and let's call this spark source cached out ground source, copy paste, out spark source. Preparation is the most boring part of this, so what I'm gonna do now is that I'm gonna cache these out like I did last time. As soon as they're done, I'm gonna get back to the video, so you don't have to watch my boring PC calculating things. The frame range, yeah, don't forget the frame range. That is nothing but this again. Copy parameter, paste, save. It's a bit boring, but now it's going to be super cool once we get all this information already, because with these many light points we can almost iterate our particle simulation to be so much faster. And open scheduler, yes please. So I'm gonna pause the video now and we'll get back right after it's over. Okay, so this caching is finished now. Let's turn on load from disk. And if we are only visualizing this, we should be seeing our points being loaded fairly fast. And I'm sorry. And okay, so we have some points stuck there. We need to investigate. Okay, and then we have this guy here. That is the. Okay, cool. So let's begin now by creating the some attributes for this. Let's create some noise. So what we need to do now is that we can merge these guys. Let's create some random stuff. Let's bring in, if we bring in this guy, and this guy, and this guy, so we can see what's happening. So there's this suspicious points there, which we don't need. We're gonna clean that up. But as you can see, what we created is pretty cool, because now we get the source points, and then the ones on the ground. Okay, I see that you see our antennas are also creating these source points, which are, I think, a little too much to our taste. Okay, so we may need to decrease the radius, but for now we will continue. So let's drop in a walk. Let's create some random stuff. So what we can do is, okay, we can create a total noise, so we don't emit from everywhere the same amount, and the behavior is different by setting some other attributes, and possibly randomizing some velocities, etc., just to break it up. And let's connect that to colors so we can see what we are creating. And okay, and then we can create in here, let's call it randomize swap. Okay, and we already have some velocities right here. They are copied from the ship itself. And okay, and so we have this. Let's also use this guy as bind export. Let's export this out as a mass, so we can change the behavior in we can affect we can override the forces, the amount of forces, by using the mass that is already built in. And let's create we can just randomize. Let's create a random number using position, and let's multiply that by the velocity, and output the velocity, so it's it's randomized. Now I think that creates 0 to 1. So okay, we're just creating random stuff, because in nature everything is very random, and we don't have that ground level of detail with rocks and trees and everything for every particle to go their own way, so we just have to fake that kind of information basically. Okay, so since now we have this, let me see, let's plug that into a particle sim and see what happens. Okay, so the other thing that we don't want is that probably, so what happens is, because we're filtering everything out by speed, right? But you see, some things are still visible because there's still such a slow motion, so we probably want to get rid of that as well. And we only notice this after we cache out, and then we start scrubbing basically, so which means that we can build that information before the caching, or we just find that out now and we don't want to go back, we don't have time, so let's just do it here. So let's basically go in here. Let's do this here so we can see it. So let's go length, let's bring in the original velocities, let's put a fit range. No, let's just put a bind export. Let's call this speed. Okay, and then if we put visualization, so again, not visibility, visualize, and let's visualize the speed attribute and find our range, appropriate range. Let's disconnect this guy, and I think it overrides, but I'm not sure. And let's go from grayscale maybe. So what we want is ideally to keep, so you see the white areas are always the fastest moving. So we want to get rid of the dark guys, these ones basically, because they have a very slow motion and we don't want to keep emitting from them. Yeah, so let's get rid of them by possibly finding values that are less than 0.1 or 0.2, so we can do a wrangle again. Let's call it static point cleanup. Because we already have the speed coming from randomize ball, we can just use that. If f at speed less than 0.1, let's start with this value, remove point from myself. Let's see what goes away. Not enough. Let's go 0.2. Scrub. Okay, I think still a little bit big. Maybe even 5. Okay, that's okay. But the thing is, our distance was still way too big, and we also didn't want to emit from the wings. So what I'm gonna do is I'm gonna remove that guy, and I'm going to bring down the distance to something much smaller for both of these. And I want to check how that looks by disabling this, which is going to force all those frames to be cooked. And I'm going to recache these again, but I want to cache this here and here, so I don't have to do this again. Basically, I want to read this information all cleaned up. I don't want to do anything extra post, but everything else in the .NET that we're gonna create now. So let's say this. Okay, and now I spent like a good deal of 45 minutes almost on preparing the cache. That's actually cool. Okay, so let's wait for this to finish and I will continue the video. Okay, so the caching is now finished. If we scrub here, we should be seeing our source points. Now we're going to drop particle network, and we put the first input, and this is already has the basics, And now we need to put our scene on manual so it doesn't cook while we are trying to fetch the collision information from our previous .NET. And let's go in here, let's paste this, merge, left input affects right input, and starting frame is going to be, if I just select this guy, I think 11 something, 1155 is our starting frame. 1155. We can make our time frame, time slider smaller. Okay, we have the geo here. Make sure that the wiring is as it is, as you see, like this here. And if you now press play, we will not see any kind of emission because we need to change the emission type to from scatter onto surfaces to all points or points. All points, as I have mentioned before, I believe, emits only exact amount of incoming point numbers. So if you need more, switch to points so you can change the number with the constant birth rate. So let's put the 50,000. If we press play, now we're going to see particles coming up and bouncing off the ground. Let's turn off the visibility of the collision geo so you can see better. So now we need to add, you know what, actually let's save. We are still in the solid sim, so I'm just gonna save on top. You can version up if you want. Come on. Okay, and so we need to add gravity. Tab, gravity, force. Let's put this guy here. Let's press play. Things are falling. Okay, good. So now our goal is to use these particles as source for our next pyro, and our goal is also to use some of these for actually having a normal cache. But what we need to do is that we need to give these, I think, a short life will be more proper, but we need to bring in our collision geometry from our ship, right? So where is our cache? We need to bring in our cache. 1 second, I'm going to check this with my other scene as I want to stay close, as close as possible. Let me see. Where am I doing this? Okay. I think we had so because we had, let me scrub a bit. So we had the ground source. Was it? Did we give this a different name? Ground SRC. Oh, okay. I just saw something now. We need to. Oh, bummer. No, that's fine because I mean we gave them the same name, but we cached them out separately. So what we can do is that a group rename? Is there a group? No, there's a group rename. Okay, so let's just rename this group from ground source to Spark source. Okay, so at this stage now we should have sweet. Let's just keep it consistent. Okay, so therefore we want this guy to be the ground source. So what we can do now is in the source input we should be able to choose our group that we want to use, which is the ground. Okay, so these guys are going to be brown. So let's do that, which we don't have to do it in the pop, but for visualization purposes I'm going to do it brownish. So let's say that's sand. Let's play. Okay. So it's very slippery on this ground. Let's add some friction and less bounce, because these are not ping pong balls. Let's decrease, yeah, that's fine. Okay, so if you press play again, they're not sliding as much. Okay, the other thing we're gonna do is we can add a little noise to this, I think. So what we can do is, well, actually, you know what, let's rename this first to ground source. Let's duplicate this guy. Very short lifespan, and let's call this one our other group, which was spark source. So let's give this ground source. Let's call this spark source. So I want this to have a bigger inherit velocity. Let me see what happens. Well, that's too much. Okay, and then I want this to be colored by the ground source. So this is only coloring the ground source. So let's call this sand or soil, and let's copy paste this guy, and let's this time fetch spark source. Let's do a ramp based on age, and let's give this like a fiery, that's white, range yellow, wish orange, okay. But this is living way too long. We need to give this a really short lifespan. Okay, so they'll. Okay, we need more. Let's give that. Let's give it a bit random as well. So they go along sideways, I think. Yeah. Okay, the inherit is too much. Let's put it back to 1. Okay, I think this brown ones can. Okay, I wonder if the if this is okay. Do we have the? Let's turn off the guide. Let's. Do we have this? It should be like that. I should say the settings. Let's check. Let's look from the camera. You should always work in the camera context. It's better. Okay, I guess we can use more lifespan, then probably a little bit of drag as well. Okay, this is not doing what I want. Let's add pop force to this stream, I think. Let's keep it organized. And this is, I want this to work on only the spark sources. Let's give it a amplitude of 10 just to see if it's working. I think it is. Let's give it a much bigger swirl size, 20 meters. Okay. I'm not sure if it's working, so I just want to exaggerate this. Oh, yes, it is working. Okay. That's too much, obviously. Okay, that's still too much. Let's go maybe 20 meters. Okay. And you know what I want also? I want the sand particles to emit brown smoke. So what I'm gonna do is, come on. Oh, sorry. Yeah, let's just be here. I'm going to create a very nice short lifespan for them as well. And I think we should also try to interpolate the birth position. Okay, maybe not at topology but point velocity. That's gonna help us a little bit with the stepping, that otherwise we may need to go higher sub steps. And okay, and I think we can also, okay, let's change the life expectancy of the ground as well, because I want to emit, okay, even shorter for both of these. I think they're too long, and then we can later we can also do a particle sim if the effect itself to render like a spark. Okay, so let's use these guys now for our emission, for our volumes. Okay, and now what we can do now is that we need to get out of this layer, because we have two, okay, let's call this volume source. We need to copy this name, and we need that information because this will get out everything, right? It gets out the collision also, but we just need the particles out. So that's gonna do the trick for us. So what we can do, I think this is, honestly, I think these particles are still too, okay, if the particles are too long during the emission, if it shows up too much, we're gonna make them shorter. Okay, so let's now, because we have the fiery look, so we can use that on how much we want to emit, right? This is the first impact, so the first impact is emitting more particles, more heat, so I guess we can use that for to multiply the amount we are going to emit in the dop net. So we can, let's drop in a point warp. Okay, so what I want to do now is I want to create some variables that are a bit more random, just to make the Pyrus simulation a bit more interesting. So let's bring in velocities to measure the length. So this gives us a speed, and then I need to put a clamp here, and so we get the speed, and we're going to clamp the speed, and I don't want to have 0, I want to have 0.1 minimum. And so now what I want to do is that I want to put a luminance, so this is going to measure the luminance value of our current color, and I want to multiply this with my clamped speed. So if it's slow, it's gonna go darker, because we have some browns and we don't want to emit forever, right? So it's gonna get multiplied by the speed, basically. And then let's go bind export, sorry, bind export. Let's call this luminance, the new luminance. And I think that's okay for this level, and now we can convert. Well, I mean, in the next one I did it with an attribute wrangle, but I think we can just do this here, because in my previous scene I put an attribute wrangle here, and I said fuel equals luminance times 2, but we can just build everything in here. So let's call this volume source attributes, and in here we can say then bind export, and let's export temperature exactly as the luminance. So let's call this temperature. Oh, sorry. Temperature. Okay, we should get the value here if we have the flag on. Height, temperature. Okay, and let's get the density out. So let's copy this guy. Let's say density, and I would like to be able to multiply these values with some other some slider outside this as well, so we're going to add that as well. So we have temperature, we have density, we need fill now. Let's copy paste this, fill, and then what we can do is that we need to give this a good name. So this temperature export, density export, and fill export. Fill export. So let's drop in a multiply for each one of these. Let's organize our scene a little bit. Excuse me. Okay, let's copy paste, drop it, promote the second inputs of each multiply and give them a meaningful name. So the first one is temp mult, temperature multiplier. Second one is density multiplier. Mult. Oh my god. Density multiplier. Density mult. Okay. And the last one is fill multiplier. Fill mult. Okay, so now finally I think that's about right. So we can also multiply our yeah, because these velocities are probably too clean for what we want to achieve. Yeah, so what I want is to give these, I want to be able to also manipulate this before going into Pyro, so I can affect the I mean how much I want to inherit from the velocity, and I can do this in inside the .NET as well, but since the goal of our tutorial is production oriented, and one of the things that we are asked to do is to create rigs, right? So we kind of tend to, so which also means that in some studios we are going to be restricted by amount of licenses, and occasionally there will be more core licenses than master licenses. So with this kind of approach that we're doing here, we are less binded to an FX license than a core license will do the job, because we won't have to go inside. Instead, we're going to directly manipulate our sources outside, which is not possible in a core license. So let's create a random based on ID, and this is creating now a value. If I plug this in here, you'll see it creates a a random value from 0 to 1, which we can use it to, so we can fit this to a different value, and then multiply that with the velocities. It will give us a randomized, well, we need to export one the integer input, one the integer output vector. It's going to give us a random stuff. So if you put a multiply here, bring in the original velocities, multiply it by this guy, and if I, well, let me plug it in as a new velocity so you can see the result out here. Yeah, it's just kind of break the straightness. Okay, you can see the difference, right? And we can obviously, if you put a multiplier here again, make these numbers much bigger. This is gonna, let's call it well, randomizer. If I paste this, okay, and if it's by default 0, so all the values are gone. But if I put this here, and it's going all over the place. Let's leave it as 1 now. And I wonder if we're multiplying it. What if we add? Should we add this instead? Let me check. I think this should be. I think this would work better if we just add it. Are they all going down or? Okay. So let's keep it multiplied. Okay. This is obviously too much. Let's leave it at 1. And now we can do a little bit of attribute cleanup. Attribute delete, because this it has too many attributes from here. And we want to preserve color. We want to preserve ID, density, field temperature, velocity, and age. Okay, and so now what I want to do is the Stockner angle is that if particles are slower than, because we're going to use this as source for smoke simulation, right? So if they're really slow, we don't want them to keep emitting. So let's put this little code here. Float, creating a speed attribute called a float speed attribute, which we need to measure the speed. We are going to use length 2 because it's so much faster. We are not after the correct values anyway, so we use length 2, and it's going to make this will make a huge difference in bigger scenes. So if speed is less than 1, we want to remove point on itself. It's pt num, and I want to have another attribute if f at h is bigger than 0.5. I want to do the same thing. Remove point. Let's copy paste that instead. Okay, and this will work, but we can also write this in a completely different way. It is more reasonable and correct. So that will be if speed is less than 1 or h is bigger than 0.5. And let me see parentheses here. There's one here, one at the beginning, That literally means the same thing as what is written on these 4 lines. Okay, that should also up. Yeah, okay, sorry, just missing one here, not there, here. Okay, and let me see. Okay, so this is from all the connection sides. I do also want to emit from base geometry itself. As it's spinning in the air, I want it to emit particles, volume, sorry. So anything that is moving, I would like it to like them to emit particles for a while. So that's what I will add now. Let's drop in a null here and let's hook it to base render so it's all the way coming down here. Actually, this, I don't like wires everywhere, so let's drop in an object merge and let's just drag the base render into object 1. So let's call this in base sim, and we can then scatter some points on this geo, which is going to, let's put the number, what's like 40,000 again. This should inherit velocity, because we're gonna need that. So let's say this is just smoke, right? So let's drop in a warp swap, point warp, and let's dive inside. Let's measure the length, and let's drop in a fit. Okay, let's you know what? Let's no, that's fine. So this is now fit. We need the maximum value for this simulation. We can always promote the maximum and make the range automated, but I think that's kind of necessary for now. So right now we are exporting the speed, the total measured speed to color, so it's going to give us the highest value, which is 104 generally. So what we can do is that we can put the source max to a, I don't know, a value like, or we can just export it out so we can adjust it from outside. Okay, and then let's put a ramp. So we kind of like normalize the speed to 0 to 1, and then we're gonna put a ramp, and let's put a bind export. Let's say this is our density. We just want to emit smoke from these ones. Just hook it up to CD so we can see the result. So if you increase the minimum amount, maximum amount, anything that is moving slower will get values closer to black. So as you can see, as soon as our ship hits our chimney, we get these bright colors, emitting smoke, coming to a rest slowly, and no more emitting smoke. So basically at this frame, let's pick something like this. We don't want to emit anymore. Maybe something like that. So this means that we need to bring this guy up. Okay. Yeah, that will do. Boom. Okay. No, it's too high. I want this to be white. Okay, we can always key we don't need to. Just because we're in Houdini, it doesn't mean that we have to make everything procedural. In the end, after all, we're making a movie. It's not really that important that everything is running automated. So what can we do now here is that we have the CD, we have everything what we need. So what we can do, because we don't want this to emit all the time, and we're emitting from points as well, so we can animate, like I said, so the amount of points. So drop in a delete node, switch the points, change the operation type to range. So let's say this is 100%. If I increase this now, you'll see the points are going less. So I can then say at the very first frame, I'm going to key this guy, it's at 0, and I don't want anything to be removed yet, so let's put another key, and then gradually things will go to 0. Let's, I don't know, here, so remove everything. Okay, so if you press play, points will get less and less, emission will diminish together with the decreasing attribute value. So let's merge these guys now. So if you press play, okay, seems like we have some cool sources. So what we can do now is that anything that has a density of 0 we really don't need. So let's get wait, our density is a vector. That's not what I want. This needs to be a float. Here I think we need to change that. Yeah, that's correct. Now it's correct. So anything that has a density of 0 I really don't need in this cache, and for the sake of optimization, let's get rid of that. Attribute wrangle if density equals 0, remove point. I think that's the most wrangle I use ever, like just removing points. So it didn't work. I did something wrong. No, it's okay. No, that was correct. But the 0 is too small. Then let's say if it is less than 0.2, and that kinda did that. Okay, so these are our pure smoke simulation source points, and we have everything we need. We have we don't need color actually. Let's get rid of the color as well. Attribute delete. I can use it here. So we don't need the color. We should do a proper spark simulation. So we have everything we need for a cool pyro simulation. So what we can do now is that we can cache this out real quick. We have the color coming from where? Here. I don't need color. All I need, I don't need age. I don't need ID. I don't need. Yeah, that's fine. Okay, this is not gonna make too much of a difference. Okay, so let's drop in a file cache node. Let's call this pyro source. Do we have any other pyro source? Let's be more specific, so I don't want to override files. Pyro solid sim source, and we want to cache it from 1155. So let's break this connection 1155 to 1300. Let's save. This should go fairly fast, and then we can start tweaking our creating our second .NET for an explosion. And come So since the next step will be a long process, I'm going to end the video here, so we can start a fresh one for the big explosion. Thank you.